Okay, hello there. Hey, we're going to go through this quiz prep page. It's been handed out a while back. It's a lot of good practice for the test coming up. So let's get started. So rates and unit rates. Find each unit rate. So I want to find the unit rate. Clearly state the rates. Clearly state the rate with units. That means I'm going to have to add the words that describe the meaning of the numbers. Round to the nearest hundredth if required. So maybe it needs it, maybe it doesn't. Okay, so 540 feet in 30 seconds. I can write that as 540 feet in 30 seconds. I'm going to write it like a fraction. I think I'm going to use a pen because that doesn't seem to show up very clearly. 540 feet in 30 seconds. So you can see I wrote it as a ratio. Now, can this be simplified? Of course it can. Well, the first thing I see, I can factor out of 10 from both these because this is 3 times 10. This is 54 times 10. And I can cross off both zeros in that case. So I have 54 over 3. Can this be reduced? Yes, it can. 5 plus 4 is 9, and 9 is divisible by 3. So that means this is divisible by 3. And of course, 3 is divisible by 3. That leaves me, how many 3's going to 5? I'll get 1. And that'll leave 2 left over. How many 3's going to 24? 8. So 18 over 1, or 18 feet per second. There is my unit rate. It's a unit rate because it's out of 1. Out of 1. Remember, unit rates are out of 1. Number 2, I have $108 for 6 pounds. I'll write the units over this time. Let's see. I can divide both of these by 6, actually. If I divide, I'll do it in 2 steps. I'll do it by 2 first, though. If I divide top and bottom by 2, this leaves me with 54. On the bottom, it leaves 3. That was kind of a surprise. Well, we know from here that's going to be $18 per pound. Who would have thought it? Okay, well, that was just kind of an accident. Those things came out to be identical. Complex fractions, right? Because either top, bottom, or both are fractions themselves. We want to simplify completely until we can't reduce anymore. So this is the same as 8 over 1 divided by 4/9, right? Top divided by bottom. And if I remember, when I divide by fractions, I can use my keep, change, flip process, or multiply by the reciprocal, so the first number stays the same. The division becomes multiplication, then I have to give the inverse of 4/9, which is 9/4. So I could just multiply across, go 8 times 9 is 72, 1 times 4 is 4. And if I divide top and bottom by 4, yeah, both of these are divisible by 4. I'm going to have half of 72 is 36. Half of that is 18 again. So 18. Or, so my answer is 18. Or if I do it this way, I see that I can get 8 is the same as 2 times 4. And if I do that, 4's will cancel out. And so on top, I'm left with 2 times 9. On the bottom, I'm left with 1 times 1. I have 18 over 1, or 18. Okay, now I have myself a mixed number, so I'm going to first write it as an improper fraction. 3 times 3 is 9, plus 1 is 10, so I have 10 thirds. That's what I have are thirds. On the bottom, I have 8/12. So this is the same thing as 10 thirds divided by 8/12. So if I did keep, change, flip, I have 10 thirds times 12 over 8. Again, I have to give the reciprocal of this. So if I did this, I would have 120 over 24. I'm going to use the rule of can I reduce before I compute. Because 12 over 8, if I divide top and bottom by 4, so if I divide this by 4 and this by 4, now my problem becomes 10 over 3, that comes down, times, now I've reduced this into 3 over 2. Now that's a lot friendlier looking, isn't it? Because look, the 3's cancel out. That means that becomes a 1 and that becomes a 1. I'm left with 10 over 2, which is 5. So once again, reducing before computing makes things easier. But let's check it with this. What is 24 times 5? Right? So I'm trying this. I'm testing out this answer by multiplying. Oops, not multiplying. I'm multiplying the bottom by 5 to see if I get the same thing on top. So 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12, 120, yes. That will be the same. Or if I think about it this way, let's just make sure that I didn't create unnecessary confusion. I'll divide both of these by 2. And that'll leave me 60 over 12. Oh, and 60 divided by 12 is 5. Number 5. Is the relationship proportional? So I have a relationship, and they're asking, is it proportional? And then it says, clearly show if the relationship has a constant ratio between the two quantities. I have two quantities. I have fuel and I have cost. So in order to see if it has a constant ratio, again, constant ratio, I have to test each one of these. Now I'm going to write this as cost per gallon because that makes a lot more sense in my brain. So I'm going to have 15 over 6 in this case. I'm going to have 20 over 8 in this case. And I'm going to have 35 over 14 in this case. So let's just simplify all these. I can divide both of these by 3. And that leaves me with 5 over 2. I can divide both of these by 4. And that leaves me with 5 over 2. Well, so far so good. And 35 and 14, I can divide both of those by 7, can't I? And 35 divided by 7 is 5, and 14 divided by 7 is 2. So sure enough, there is a constant ratio. So my constant ratio, remember, my constant ratio is this. In this case, 5 over 2. So I can fill in my sentence here, which we've been working on. The relationship between cost in dollars and gallons is proportional because the ratio of dollars over gallons is constant. And I'll state what the value is this time. Constant. It's 5 halves. So there we go. So again, we were just checking to see, is the relationship proportional? Okay, moving on. On this side here, what do we have to do? We have to convert the given rate, there's a given rate, into the rate indicated. It looks like you've got some organization to set up the problem already done. So I have $3 per gallon. Well, how many dollars per pint is that? Well, I do know that in 1 gallon, let's see, 1 gallon is equal to 8 pints. So I can set myself up a unit ratio. That is 1 gallon is equal to 8 pints. Now, the beautiful thing about that is I have the same unit on the bottom and the top, so they're going to cancel out. Excuse me, that's distracted me. And I'm left with 3/8 dollars per pint. I suppose if I convert it into a ratio, I would get 0.375 per pint. Let's try this one. So I have yards per minute and I want feet per second. Well, both of these units are different this time. So let's change the yards first. I know that 1 yard is equal to 3 feet, right? So those will cancel out, yay. And minutes, and I want seconds. Well, I know that 1 minute is equal to 60 seconds. So the minutes and the minutes cancel out. And I'm left with feet per second. Oh, happy day, that's what I want. So now I just have to do the math. So this is like 12 over 1, so I have 12. Right? Everything on top, I'm going to multiply. 3 times 3. Right? And if the stuff on the bottom, I have to divide. So I have 36 over 60. I can divide top and bottom by 6. Looks like I can divide top and bottom by 12. When I do that, I have 3/5, or 6/10, right? If I multiply top bottom by 2. So I have 0 and 6/10 feet per second. I have 3/5 feet per second. Let's see, what does it say? This says, the table shows the number of calories an athlete burned per minute of exercise. So here's the number of minutes. Here's the number of calories by minute. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. So in the previous problem, we asked, is it proportional? We checked by constant ratio. Now we're being asked to check for proportionality by graphing. So what I need to do is I need to first plot these points. So this is the point 0, 0. There's 0, 0. And I have to plot 1, 4. So there's 1, 4. Then I have to plot 2, 8, 2, 8. And then I have 3, 13. 3, 13 is going to be between 12 and 14. So I have this. Now I need to draw a line. So I need myself a straight edge. And of course, the moment I want a straight edge, I don't have one instantly available. So here, let's use my Safeway card. So let's see, if I put it down here and I try to line up these 3 dots, this is kind of interesting. It looks like I want to make sure it crosses the y-axis. And this is kind of curious because I see it almost looks like it goes through all the points, but not exactly. This point right here is being kind of pesky, and it's not on the line exactly. So it sort of looks like it's proportional because it got a straight line. Certainly those line up, and it goes to the origin. But then I got this thing, and that. So what do I say? Is it proportional or not? Well, one thing I could do is I can test, and that comes back over here. I can test if these things are actually proportional. So what I'll do is I'll check calories per minute, and then I'll have 4 over 1. See, 4 over 1, and I'll have 8 over 2. And this will be 13 over 3. If it's proportional, these things will all be the same. The 0, 0, we're not going to calculate because that's kind of a unique problem. But 4 over 1 is 4, and 8 over 2 is 4. But 13 over 3 is not, this right here is not 4. So I know for sure that this is not proportional. So the relationship between calories and number of minutes, I'll put number of minutes, is not proportional. And it's not proportional because the graph does not go through all the points. The data does not form a straight line. The graph doesn't go through. Data does not create a straight line. Create straight line. Looks like I have 1. So it's not proportional, but it was close, wasn't it? Okay, one last problem here. Solve the proportion. So we did these as cross products. So remember with the cross product, what we do is we do those two together, and we set it equal to these two. We're starting with an equation, so we have to always keep that in mind. So I'll do this over here. All right. So if I was to do a cross product, I'd do this times this. 8 times x is 8x. And on this side, I have 6 times 32. If I was to do it on this side, I would have 18x equals 3 times 42. And so what, if I was to multiply things out here, I have 8x is equal to, 6 times 30 is 180. This is me 192. if I was to multiply this side out, I'd have 18x is equal to 3 times 40 is 120. 3 times 2 is 6, 126 when I add those together. Then I have to divide both sides by this one by 8, because I'm multiplying, that's what I'm multiplying x by. This side I divide by 18, because I'm multiplying x by 18. So I have these division problems, which I could do. Or I can go back, my original problem, is any of this simplify? Yeah, I could simplify this. Yeah, these are both divisible by 8, aren't they? So this problem is the same thing as 1 over 4 is equal to 6 over x. That's a 4, not a 9. And so if I do this cross product, I have x equals 24. Ooh, look at that, one step. That one was kind of convenient. Here, I can divide top and bottom by 3. Doesn't always work out this way, but if you can reduce before you compute, this is our point. 1 over 6 is equal to x over 42. And I would have 6x is equal, right? 6x is equal to 1 times 42, or 42. I divide by 6, both sides. X equals 7. Makes me wonder, on this side, notice I keep my equal signs all nice lined up. 18 divided by 18 is x equals, and I'll leave it to you to finish that one up. Just like I'll leave it to you to finish this up. Okay, hope this helps. Remember, practice, practice, practice. Write your questions down if you have any.